Welcome to another installment of Chip Amp Theater. Hey guys, I'm going to do an amplifier shootout today. Well, both of these are stereo and they're bridged. They operate on the same power supply of 12 volts, so make a good comparison against a Class D and your standard linear Class AB amplifier. This board here is a pre-assembled tri-path TA2024 based amplifier. It's Class T, which is really a Class D. They just call it that to separate themselves from the pack. I guess they do a few little things to make it, sonically better and all that stuff, but it's really a Class D. I did review this amplifier in a previous video. I'll put a link in the description. I did have a few issues with it. One thing was heat, heat dissipation. Even a Class D amplifier needs to dissipate some heat, even though it's quite a bit more efficient than your typical Class AB linear amplifier. This is rated at 15 watts per channel, so that's 30 watts. And depending on the load impedance, it might be 85 to 90% efficient. So you're still going to have to dissipate 3 to 5 watts or so. And it got very hot during my test, so what I did is I epoxied a heat sink onto the chip, and that should help with the heat dissipation. This IC here is a TDA1558Q. It's also a stereo bridge amplifier. Of course, I'll have to put it on the breadboard because it needs extra parts to make it work. And we'll set it up, test the power at 4 and 8 ohm loads. Also compare how much power it draws off the supply. Being Class D, this should use somewhat less because it's more efficient. Well, to start this thing off, I'll use the TDA1558Q. I have it set up on the breadboard. For power, I'm using my regulated 12 volt supply, courtesy of Radio Shack. This actual regulated output is around 15 volts. Now that's with no load, or actually the chip is now quiescent, meaning there's no output. So it is a bit high. When I actually do the test, the output voltage might drop a little bit. But sitting here quiescent is drawing 132 milliamps. Of course, that's 4 separate amplifiers in this chip, and 2 are for each channel are bridged together to make a total of 2 bridged stereo amps. So you're seeing some quiescent from each amplifier times 4. Okay, music player hooked up, and I'll do the music test.
Same time our natural resources are dwindling: coal, oil, gas, water. Okay, with the development of the third world, we're just creating a ticking time bomb. Our politicians are using the same late band-aid techniques for re-elections over and over.
Well, sounds fine to me. I don't hear any distortion. Okay, now we'll get some power test measurements going. Alright, I have the 4 ohm loads, non-inductive resistors hooked up. Right there's one, scoping off the other one. Of course, we do both channels driven. Maximum clean power, so no clipping is allowed. And have the 1 kilohertz signal set up. And watch what happens to the supply voltage. When I turn the signal on, drops down to a little over 12 volts. And I'm going to have to use that as my base for measuring these things. the current is 2.9 amps, so it's actually exceeding this, so it does drop out a little bit, plus all the wiring from the supply. But anyway, let me get a measurement here. It starts to clip around there. I'm going to turn the spectrum analyzer on there. There's our clipping point. About there. 6.24 volts. So we take that output, 6.28 volts, square it, divide it by the load impedance of 4 ohms, we get 9.85 watts. We'll just round it to 9.86. And that's around what I would expect at about 12 volts. Well, you might be thinking, this chip is, it says on the data sheet it's 22 watts by 2. Where's all the power at? Well, they always rate them at 10% distortion to get high numbers. But when you rate pre-clipping, you're not going to get near that value. Plus, they rate them at 14.4 volts. And if I did that, I'd probably get around 13 or 14 watts. But I'm measuring at a little over 12 volts, so I'm only going to get about 10 watts of output. And here is the schematic, by the way. Of course, you just go online and download this data sheet if you want more information about it. Alright, well, let's look at the 8 ohm power ratings. Okay, 8 ohm time. One of my resistors is missing, so I'm just using that. It'll work. The other one's, of course, scoped. Getting about 7.045. And that comes out to 6.2 watts. I had to get the variac involved here so I can get the voltage right at the amplifier. The supply voltage measured about the same. Okay, I have the Class D board hooked up, TA2024. I couldn't find that little connector for the input, so I had to solder some leads on. On the supply connection, I put this 2200 microfarad cap. I'd recommend doing that if the power supply leads are long. If they're a good distance from the battery or the main supply filter caps, because under high current stresses during like a bass drum beat or something, the current might pull the voltage down. This will help a little bit keeping the supply voltage up so you get good power output on the transients. But anyway, have it hooked up to the speakers and we'll do a quick listening test. That sounds fine to me. Sounds just like the other chip. I don't hear any distortion or any issues. Okay, let's go ahead and do the power test. Okay, power test. Like always, we have the 4 ohm loads connected to both channels. And there we go. Kind of interesting though, we have some sort of instability as I crank up near clipping here. It's some oscillation. It's a very high frequency. I don't think you'd hear it, but I'm just going to go ahead and use that anyway as my before clipping level test. I'm going to reset this. We'll say right about here is clipping level. So we're getting 5.98. Maybe I can coax 6 out of it. Yeah, we'll say 6 volts. That's about there. Okay, I went ahead and did the 8 ohm test. And here are the results. TDA1558Q with 4 ohms, both channels driven. B4 clipping is 9.86 watts per channel. And for all tests I used 12.28 volts. And with that load, I was drawing 2.9 amps off the supply, or 35.6 watts total. So you take that value, divide by this value times 2 because there's 2 channels, and it's operating at 55% efficiency. Now with the Class AB, the depends on the... somebody's getting hungry. Hi! Hungry? Yeah, he's hungry. But you're gonna have to wait, Snickers. I gotta finish up the video. Now, yeah, like I was saying, depends on the output, but with a Class AB amp, it I can't hold this paper down. You kind of get a curve like that, and it depends on the power. So it may not be at the maximum efficiency point, but yeah, it's usually somewhere around 60-65%. 4 ohm loads are harder to drive, so it's a little bit lower. With 8 ohm loads, I was getting 6.2 watts, and the efficiency is 56% measured. On to the TA2024. The quiescent current was 70 milliamps, so it is better. It's about half that of the TDA1558Q. And you know, it could vary depending on the chip that's in use, because I've seen some that are higher, Class D chips that are higher. And let's see here, 4 ohms, let's get 9 watts even. And I was getting 70% efficiency there. With 8 ohm loads, I was getting 6.67 watts. And the efficiency was 74%. Should be higher, but I don't know, the heatsink still does get pretty warm. There could be losses somewhere else in the circuit. I didn't notice these getting, you know, very warm, these filter coils. Well, that's just what I'm measuring, so that's it, pretty much. Just a comparison between a Class D and a Class AB stereo bridge amp. Thanks for watching.